So the ray from slightly may not be parallel, may not be parallel. Not parallel. Okay. Then again the ray will be, so this is the, okay, this one. So here this is are very important for me. Fine. So this angle is 90 degrees. This also 90. This also 90. So this angle also should be 90. Yeah. Looking at the prism diagram. Hmm? Okay, fine. So how come this line will be parallel to this? This line will be parallel to this. I'm not doing any magic here. It's all about the geometry, nothing big. Okay, fine. So this will be normal, no? Okay, this will be normal for this face. As these two faces are perpendicular, so therefore this normal will be parallel to this face. And these two faces are having angle 90 degrees. Therefore, this normal to face 1 will be parallel to the face 2. So therefore, these two normals, the angle will be 90 degrees. This is the central theme of your problem solving, the geometry. Okay, let's all will go for it. So this angle is what I, R1, this R2, this R3. This should be the R4, R4, R5, R6, R7. This, not needed this line. Let's get into some. So from this R1 plus R2 should be 90 from Prism concept. Similarly, R3 plus R4 should be 90. Similarly, R5 plus R6 should be 90. And this is the emergent tree. Huh? And this is the incident tree. I don't have a place. Like it here. And they're in fact parallel. Huh? You can see these two are parallel. So if emergent is parallel to incident tree, so therefore now what we can write something about the R7 and high and 90 degrees. So these two will become like a triangle. So R7 plus I should be 90 degrees as they're parallel. So we'll have one more. So this is what I 90 degrees. This is R7. Therefore, I plus 90 degree plus R7 equal to 180 degrees, or R7 equal to 90 minus R. Very important. You can't solve the problem without this data. Let's apply the Snell's law at all the faces. So sin I mu sin R1. So this will become R1 I can write as 90 minus R2. So this will become sin I is equal to mu cos R2. Or let it be R1 as it is. Huh? Let me not disturb. Let me not disturb this. And now afterwards mathematics. Huh? So next again mu1 sin R1 equal to mu2 cos R2. Mu2 sin R3. Yeah. Applying Snell's law, mu1 sin R2 should be equal to mu2 sin R3. Any replacement can we do here? Mu1 sin R2. Okay, mu1 sin R2 I can write it as 90 minus R1. R3 I'll keep as it is. Mu2 sin R2. This is one equation. This is a one equation. Next equation is this one. Mu1 cos R1 equal to mu2 sin R3. Next again, applying the Snell's law, mu2 sin R4 What is R4? I have to replace R5. That is, I have to replace R4. R4 I can write as 90 minus R3. So why you are doing like this? Just to bring the condition, because all these angles I should eliminate. I can eliminate these angles only when I square and add trigonometry. What is R5? R5 will be 90 minus R6. Mu2 cos R3 R4. Okay, so problem is there with my brain now. Not thinking properly. This is R3. Sin of 90 minus R3 should be cos R3. Mu2 cos R3 should be equal to mu3 sin R5. This is one equation. Then last one, mu3 sin R6 equal to sin R7. So R6 I can write as sin of 90 minus R5. R7 I'll write it as sin of 90 minus R. So mu3 cos R phi should be equal to cosine. So this is the now all these angles should get eliminated so that I'll get only the mu. So how to eliminate this all these angles here? So I'll call this equation 1, 2, 3. So we have to do some calculations such that the angle should get eliminated and only there should be the refractive indices must be there in the equation. I think adding up, squaring and adding 1 and 3, subtracting with this one. So here I'll do like this: 1 square, 3 square, minus 2 square plus 4 square. Okay, 1 square will be sine square I, squaring and adding we have to do. I'm not putting mu 2 square cos square R3. This is a 1 minus of the other side will be mu 1 square sine square R1 cos square R4. I missed some terms I feel. Sine square I mu 2 cos square 3 sine square I is equal to mu 1. I'll rewrite somewhere I missed it. Nothing but these two should equate, no? Equating to sine square I plus mu 2 cos square R cube minus mu 1 square cos square R1 minus. Okay, I'll write it a little bit lengthy. It says sine square I plus mu 2 mu square cos square R3 minus mu 1 square cos square R1 minus mu 3 square cos square R5. This should be equal to mu 1 RHS1 sin square R1 plus mu 3 sin square R5 minus of mu 2 square sin square R3 minus cos square R. We should solve all this. The angles, if you see this one, mu 1 square, mu 1 square. Regrouping, mu2 squared mu2 square cos square 3 and mu2 square sin square 3. One more similarly, similar color, pink color. So therefore this will be sin square I plus cos square I. Mu2 square will be common, cos square R3 plus sin square R3. Mu1 square common, cos square R1 sin square R1. Mu3 square common, cos square R5 all set equal to 0. So this will be 1, this will be 1, this will be 1, this will be 1. Okay, there's a relationship between the mu2 so 1 is equal to mu1 square mu3 square minus mu2 square. This will be your answer. A little bit lengthy. The calculations are, the theory is very small. So some very important things is like the diagram which I drew is something very important. Even I am also, you can see myself, I struggled here because you have to bring some trigonometry ideas here. The idea of physics is about drawing this diagram. The rest of all these angles, Snell's law, okay, one equation 1, 2, 3, 4 is Snell's law, physics. Rest of everything is the trigonometry. Okay, of all this, this is very important things. This one, these things is what student has to make observation. Hmm? Okay, let's take the next one.